Are live. So in this video, I'm just going to cover the homework problems. So for the final homework, we're going to do animations using Pygame, in particular interactive animations. So you can think about simple games or computer games in this. And so since this is kind of an interactive type problem set, I figured it would be best just to show you what the homework problem should look like. The details are posted on Compass, but let me show you the first problem. So with Pygame, you can use both the command line and Jupyter Notebooks. In all the videos, I'm just going to use the command line. For some reason, Pygame doesn't work too well in Jupyter, at least on my computer. It sometimes seizes up the web page. And so it's just a lot easier, at least in my case, to use the command line. So in the command line, I'm in the directory, and I can type Python. And then I'm going to do the first homework problem. So this is homework 12, and then we're going to do -1 Python. And so what this simulation is going to show is a bunch of bouncing balls, and they're going to be color coded. So let me just show you the simulation first, and then we'll go through it again. So it starts up, we have a bunch of balls with one ball initially blue, and then anytime a blue ball touches a red ball, it converts it to a blue ball. And so I got the idea of this simulation from a video I saw kind of early in the COVID pandemic, kind of showing kind of the transmission of the virus and kind of arguing for social distancing. So that would be one simulation. So all the balls are moving around. They're using, their motion is described by Newtonian mechanics. And basically we have elastic collisions, both among the balls and between the boundaries of kind of the box in the system. Let me just show this to you again. So I end it, I type Python homework 1, and then you see it, the one ball blue, and then it starts coming over and converting everything to red. And you see pretty quickly once you kind of hit a critical mass, basically all the balls transition from red to blue. And so that is your first problem assignment. The second one is kind of a similar idea, but here we're playing the same idea kind of with pool, or a simplified version of pool. So this is the second problem. And so we have it start up. And so I have a bunch of red balls. So I have 9 red balls and then 1 blue ball. And the blue ball is the one I can control. And so I'm going to use my arrow key. So if I hit the arrow key up, it increases the vertical velocity. If I hit it down, it'll stop. I hit it down twice, it'll speed up. If I hit it left, I'll kind of get much faster, and then it bounces off the walls. And then if I hit it up, it'll increase the velocity. I'm not holding the keys anymore, so this is just, you can think about point forces. But then we start seeing all the balls start colliding with one another. So here I'm increasing its size, and then I here have all the collisions. So again, what I'm doing is just using the arrows to adjust kind of the base velocity of the cell. Now, of course, that velocity can be adjusted by collision. So here my ball's moving, and then I'm going to add some leftward force to it, and then I start having the collision with this. So I kind of have kind of a pool type game scenario going on. Again, the mathematics and the details are provided in the homework, and I give you a lot of similar kind of examples that are posted on Compass. Again, all these files have to be run from the command line, but you can also cut and paste them and put them into Jupyter and try using notebooks to do this. As I mentioned, my Jupyter doesn't do it well, but last semester, a lot of students were able to do their animations in Jupyter without a problem. I don't think I have the most current version uploaded. So just one more time, I started up. I type Python. So here's my directory. I'm in kind of week 13. And here's Python homework 12.2. I hit enter. I start up. And again, if I just hit it once, hit the up button once, I get an upward velocity. I hit the left button once. Now I have an upward and leftward velocity. And then I can hit both of them again once, twice, and I get a little bit more velocity. And then we start having the collisions in our system. And hit it up again. And then once you get it going, you can kind of control it around. Then I can try to maybe avoid. Well, I can't do it too well, but I can move around. Maybe I can try to avoid the other balls or try to smash into them as best as I can. And so that is your second problem assignment. Your third homework assignment is to do the snake game. And this was a suggestion by a student last year. So this is problem 3.python. And so what I have here is, after initial adjustment, is I have kind of the line going on, and here I'm controlling it. So it'll move in the direction until, if I hit the left button, then the up button, then I hit it left, and I'm trying to avoid kind of self-collision, but if I collide, I stop, and then it also gives me the score, 135. Ignore the hi command, that's just from me doing debugging. I forgot to take that out. I can run it again. If I run it down, I come up, and if it hits the side, it also stops and kind of does a collision. Start up again. I move up, I come around, move around, come around, and then if I hit here, it stops. Each time I'm moving, each movement is adding a square that's 20 by 20. And the up, down, left, or right position is just telling whether I'm moving up, left, down, or right. And again, it'll end if I collide in myself or if we collide with the boundary. So I can try to come around. If you do it really well, I can come up here. And then potentially you can, survive as long as you can. I think the first time I actually played this game was on my ancient Nokia cell phone, which was kind of the only program on it. So relatively straightforward. This is a fairly standard kind of simple type computer game. And again, we're using the arrow keys to control the motion. So with that, I'm going to stop. The details, again, are posted on Compass, with the size of the board and some of the equations used for math, and particularly the collisions. And also, lots of samples have been put on to the Week 13 folder. And in addition, there's the other videos, 13.2, 13.3, and 13.4, where I kind of go into programming and animation. If you have questions, please post them on Piazza or put them in the comment section of YouTube. Thank you.